Hello. I wanted to go over some of what I think is the best practices for using the new input system. It can be a bit of a jump to go from the old input manager to this, and I wanted to share some of my my journey trying to make my way through it. So I'm going to show this by creating a character controller bare minimum thing, so move and jump, for example. And generally, the first thing you would do is create what's called a new input actions asset. I'm going to call this character actions. And going through what a bit of these things are, a control scheme is what would be the type of device input you would use. So you would have a gamepad control scheme and a keyboard control scheme, for example. So I'm going to add one called keyboard first. I'm going to add a required device type. So in this case, a keyboard is required for this control scheme. That'll come into play later when the system tries to automatically figure out what the best control scheme is to use for the device you're trying to input on. And now that we've got that, we want to create an action map. In this example, I'm only going to have one action map, so I'm going to call it default. This is capital D. But in the future, you would want maybe one for movement, one for vehicle control, one for walking, and one for the UI. And then you would enable and disable these action maps based on the context of what your project is trying to do. But for now, this is default. I'm going to just delete that initial action. And I'm going to create a new action, and I'm going to call this move. So in the old input manager, this would be horizontal and vertical, but combined into one. So in this case, I want a vector 2, because this is going to move our character around. And I'm going to bind that to some kind of input. And because this is a keyboard, not a gamepad, we need to bind that to either the arrow keys or WASDA or something along those lines. So I'm going to add a vector 2 composite binding and call this 2D vector, why not? Oops, let me delete the old binding. There we go. And for the up binding, you can come over to path, just choose listen, hit the key you want, select, rinse and repeat. There we go. And you would do the same on a gamepad. So there's move. I'm going to create another action and call it jump. And this action type is a button. And I'm going to bind that to the spacebar. And then that's pretty much all we're going to do here for now. But on the jump action, we'll come back to this, but the interactions option is something that is very important, but we'll get back to that. And I'm going to choose save asset, that's important too, or choose autosave. And then we're done with that for a little while. I'm going to create a capsule for our character, remove the capsule collider, and add in the character controller collider for the sake of this example because it's really easy to use. I'm additionally going to add the player input component because this is the new input system's kind of easy way to get access to the new actions you created. And it also helps greatly with dealing with local multiplayer, like with multiple gamepads or split keyboards or anything like that. And it wants a reference to the input action asset that we just created. So I'm going to drag that onto here. And I'm going to create a new script as well. And this is going to be called character controller input. And I will also add this to our game object. In the player input component, it has a default scheme In a lot of cases, you can just leave this and say auto switch. So if you enter different control types, or if you start using the gamepad, it'll just switch on its own. And in the default map case, we created one called default, so we're going to use that. Obviously, choose whichever one makes sense. And I'm going to ignore everything except the behavior part for now. These are a lot of options, and they all do very different things. Send messages, the default option, is the one I'll be covering in this video. And this does things a very simple way. It doesn't give you full control over your actions and inputs, but it is pretty quick to get working. And that creates some messages, and it'll give you some information down here, like send message to game object of on device lost, on device regained, on controls changed, and then on move and on jump. On move and on jump are generated from our character actions. And those will change based on the definitions in your input action asset. Anyway, jumping into character control, the first thing you want to do is using Unity Engine.InputSystem. And I want to start by getting a reference to my character controller, because that's where we're going to be getting input, sending our input to. Let's call that character controller. Just going to make the assumption that it's on the same object here. And now we can start getting inputs from player input and our input action asset map by implementing on move with a variable type of input value, and on jump also with a variable type of input value. We can get some information about when an event occurs. So move is going to return a vector 2 because that's what we defined in our action map. So we can do a vector 2 vec equals value dot get vector 2. And on jump, because it's a button, it's only going to return true or false. And there's actually a helper function in here called value.isPressed, which I will use in a little bit. I want to move on by caching these values somewhere so I can use them inside of a fixed update loop, or whenever I need to, really. So I'm going to create a variable called moveVector, another variable called shouldJump. So this is a variable, and it's called shouldJump because when you push jump, you may not be on the ground. There's a bunch of conditions why you shouldn't jump, and this should only be set when the on jump callback occurs, and you should actually jump. So in this case, if character controller is grounded and value is pressed, should jump is true. And here, because we're going to use normal physics gravity here, move vector dot x equals vec dot x, and move vector dot z equals vec dot y. So we go from a 2D joystick to a 3D move vector. I'm also going to create a variable called velocity here, and some public variables to help tune our character a bit. So here's speed, jump speeds, and gravity. So now inside of a fixed update or physics loop, we can start to set our velocities. So rudimentary character control. If character controller is grounded, velocity.y plus equal gravity times time delta time. So this increases our gravity over time if we're on the ground. Sorry, if we are not on the ground, apply gravity. And then if should jump, then velocity.y is overridden and set to our jump speed, and should jump is set to false, so that the only time it can be set to true again is by our callback. And then velocity.x is equal to moveVector.x times our speed, and velocity.z equals moveVector.z times our speed. And now we can apply this to the character controller by doing a character controller.move velocity times time delta time. And there we have what should be a rudimentary character controller. We'll set our speed up to, I don't know, 8, jump speed 2, and gravity to negative 9.81 because Earth. And when I hit play, we can move our character, and we can jump. Oh, it's a sad jump. That's better. Increase some gravity, increase some jump some more. Yeah, that's looking better. Okay, so what's going on under the hood here? On jump is called when the jump action is triggered, rather performed. And under a default case, you get the value back. So in this case, I'm going to say debug.log value is pressed. So every time we push the spacebar, we should receive an on jump callback, and it'll hit our console and say debug log. Let's put that out of the way. So now, jump. So you can see I'm only receiving a true event here. And if any of you are fans of platforming games, pressure-sensitive jump is definitely a thing. So you actually don't just want when the button is pressed, you also want when it is released. And that's one of the biggest gotchas of the new input system, is that doesn't come across when you're using this send message default, just created an action, haven't read all the docs yet. And this is where interactions comes in, because you can set a press interaction, and here you see the trigger behavior. Trigger behavior can be set to press only, release only, and press and release. By default, it's press only. When you add the press interaction, you can set it to, say, release only. Choose save asset, run the thing again. And this is very telling. So when I push jump, nothing happens. But when I release jump, it gives me back a false, meaning that value is pressed as false, and we had a check in here saying if we're grounded and value is pressed as true, then jump. So you get the same callback, but is pressed is set to false. So if we go back and set this to press and release, we will get two callbacks, one where is pressed is true and one where is pressed is false. True, false, true, false. And this is effectively the new input system's default way of doing on up and on down with an action. There's one more case I want to cover, and to do that I'm going to create a new action called use. It will also be a button, and we're going to bind it to the E key on the keyboard, and I'm going to define a different type of interaction. I'm going to define a hold interaction and set its hold time to 2 and save out the asset. And in code, as you may have guessed, you can do a void on use. And we can debug out the same way. So because we set the hold time to 2, this should be called when we're holding down the use button or the E key for 2 seconds. So use, true. And when you release, you don't get anything back. So this is an example of being able to do something like long press to activate or something like that. Anyway, I hope that helps some people get started with this method of using input actions, and I'm going to cover the other options for player input in the next video. See ya.